Okay, we are still waiting for maybe 20 some students. Okay, so we'll begin in 2 minutes. Yeah, happy Good Friday. Okay, so uh, weekend soon. Okay. All right, so let's begin. So today, actually, we already started this, right? So the TCP, the transport layer, okay, TCP and UDP protocols, okay, and we will be talking about mainly TCP. Okay, majority of these slides are about TCP. But before that, we'll briefly discuss UDP. UDP actually proposed after TCP, but because it's so simple, we will have a few slides on that. But we'll move majority of the slides in the next set of slides will be on TCP. Right? So as we discussed, previously we talked about data link layer, network layer, and transport layer, right? So they're all sending packets, right? But in the data link layer, and the network layer and the transport layer, the packets are at different levels, right? So in the transport layer, when we have a packet, we call it a segment, right? In the uh, network layer, we call a datagram. Okay, so they have different names basically. Okay, and so in the transport layer, so what we address is uh, so firstly we are demultiplexing data stream because on top of the transport layer, we have the application layer, right? So you may have to multiple applications run together, even between two pairs of machines, right? So then you need to deliver the right uh, application message to the right target application. Okay, you cannot send an email message to a WhatsApp and send some WhatsApp message to the email, right? So we address this using ports, as we will see later. Okay, actually, if you have some memory about the socket programming project, we should already know that it's by the port number decide handles the multiplexing and demultiplexing. Okay. By the way, so for the final project for the graduate students, we are thinking is maybe later next week we will release a recommended project. Okay, but because this semester is remote, so we are thinking to make a bonus project instead of counting to the base project. So basically, if you have bandwidth, you can work on that. Okay, if you don't have bandwidth, we will not deduct points. Okay, we will get bonus instead. Right, so maybe 7.5 bonus. Okay, for both graduate and undergraduate students if you have bandwidth. Okay, it will be a recommended project, but you can also choose your own topic. If we approve that, then you can work on your own project. Okay, I know some students would like to work on some other projects, right? So, yeah. Okay, let's we will release that next week. Okay, so okay, let's continue. Right, so besides demultiplexing, right? So the second usage of the transport layer is we want to establish connection. Right? So it's just like a phone line. Okay, but we are using packet switching. Right? In order to maintain the phone line, we have to do the end-to-end maintenance. Right? So you cannot maintain in the middle because those routers are not doing that. Right? It's not a circuit switch. It's a packet switch. But you want to simulate a circuit switch. Right? And because it's a packet switch, a lot of people are using your traffic. Right? So you need to do some congestion control. Because that particular router to router link is not used by a pair of sender and receiver only, right? So they're potentially shared by multiple streams. Okay, what if other people's stream is occupy too much bandwidth? Then you cannot send it through, right? So we want to have a mechanism to avoid that. So the key challenge here is firstly how to detect. How to detect that there's a particular link in your route that suffer from congestion, right? And keep in mind the route is handled by the network layer, not the transport layer, right? So the transport layer, when detecting this, it can only kind of handle this at the end, right? Sender or receiver, okay? How to observe what's happening there and detect whether, hey, there's congestion, I should slow down my sending. Okay, so this is what we are seeing, okay? Another thing is that we want fairness, right? I don't want to, like somebody is using 90% of the bandwidth, I can only use 10%, and this will continue, right? So if this is the current situation, the protocol should adjust that. So finally, each of the two communication parties will be using 50% of that bandwidth on a particular link. Okay. Right. So firstly, we discussed last time about multiplexing, but because of the time is quite short at the end of the last class, so we don't have time to cover it in detail, right? So here, basically, we are talking about, think about, right? So we have the datagram network, right? So in the network layer, okay? If we don't consider the transport layer. And the datagram network in the network layer, we know it's the routers are just store and forward, okay? It looks at the destination IP address and decide where the next port it should put your packet to, okay? But it doesn't do any like states. It's a stateless connection, right? So there's no sustained connection like a circuit, right? So, but sometimes we do need such a connection, okay? When you are sending some large documents, right? Or you are, for example, so when you send large documents, it's not a small amount of packets, right? And then you want to maintain some session, right? When you are logging and do some logic, right? So all these things require circuit kind of operation, right? Not just the packet switch as individual packets. You need some state to maintain, right? And you can keep using this channel to communicate, basically, right? So the channel, the connection will be surviving for a period of time, okay? And so another thing is that the client is not just running one application, right? One is sustaining the connection. So during this period, you can send and this connection established, right? The second is you want to run many applications, like you have a browser and you are sending some emails, right? And you might use a chat to communicate with others, right? So sending messages, right? Even two people, right? So they may each run these three apps. You want a Chrome information to go to Chrome, email to go to email, and Skype to go to Skype, right? So who should the packet deliver to, right? If you just have the network layer, you just have those kind of datagrams, right? Those small packets. You don't know which application should be delivered, okay? So if you remember, the IP header has a protocol field, right? So, but we cannot rely on that, right? So if you just look at the IP layer, the network layer, right? we can, of course, use the protocol field to achieve multiple connections, right? So for example, each protocol is one connection, but actually we're not doing that, right? So all TCP is using the same protocol ID. All the UDP is using that, right? So internally in the TCP, we use port number, or UDP we use port number, right? TCP will be using the port number to decide the connection. Okay? UDP does not have any connection. Okay. And so, but the UDP also do the multiplexing and demultiplexing to deliver to the right application using ports. Okay, we will see that shortly. Right. So of course we will not use the protocol field, right? Because protocol field only have 8 bits. Right. In the extreme case, you can only maintain 2 to the power of 8 concurrent streams, right? Okay, and that's oftentimes not enough, because even though the application you care about are just maybe tens of applications, but down there your service, like your daemon, maybe you're communicating, there's a lot of other applications that's run, right? So that may not be enough. Okay. Another problem is that maybe you are the server, right? So you are the mailing server, right? You need to maintain connection with different clients using different, port number, right, on the client side. Okay, if you remember our socket programming, right? So it's very likely you are serving more than so many clients, right? So even for one application, so many streams is not enough. Okay, keep in mind that even though it's the same server, right? So email server, for example, right? It's serving different clients. Different clients have individual streams. Right? For example, if your email to the server, you don't want the message to be mixed with other people's email to the server, right? Any questions so far? Okay, I hope this is fine. Right, so our solution added a transport layer, right, to handle the multiplexing, demultiplexing. Here is a very intuitive diagram. Right? So assume you have application, then we add a transport layer, right? And then we have the network layer. Right? We know that network layer is like a one point setting out and coming in, right? So, but you have 2 applications, for example, right? So basically, for each application, you will allocate a port number as a transport layer. Okay. And let me see the animation. Right. So here, unique port for each application. Right. Of course, the unique port means a unique port in your machine in each host. Right. So for different hosts, you can have the same port, because they, it's decided by IP number, IP, and the port number. Right. So one port number is not. So if your IP is different, then the port number means different things. Okay. So for each application in one host, you should have a unique port number. You cannot have 2 applications having the same port number. Okay, so the reason is very simple, right? So each application will pass its own messages, right? If you have another kind of format of message coming in, the application will crash. It cannot pass properly, right? Okay. So yeah, so this is even the case. For example, if you are running, for example, my student is running some like a Jupyter notebook file, but we want to run multiple experiments using, for example, the Chiha, right? So, and Jupyter notebook can create multiple instances of the servers, each communicating with one particular server in the one particular host in the Chiha. Chiha has more than 100, right? If that's happening, you need to map to different ports on your client, right? So your one client is mapping to a Chiha servers, like server and Jupyter notebook server, right? So for one machine in the Chiha, okay? So that you can differentiate, hey, these messages are coming from that Chiha server, another is from this Chiha server, right? So you need to use different port number. If you use the same port number, since we'll mix, you will get, different streams show on the same Jupyter notebook, right? So then it's messy, okay? Even for the same applications, they know the message format. Sometimes you want to, you want different port numbers if you have multiple instances, right? Okay, so here is an example, right? So if you look at the orange link, so assume the host 2 is a server, right? So if you run a HTTP server, then if you are communicating, P3 and P1 forms a link, right? So IP address of host 1, P1, the IP address of host 2, and P3, right? So then you can communicate with a web server and a web client, okay? Another example is, right? So if you are host 2 is running also a mailing server, right? Mailing system, okay? Right. And then the host 1 and host 3 are the clients, right? So you can see the blue connection here, right? Go to P4. And you can also see this is the serving the client 1, okay? From the mailing server, okay? And you can also have another independent stream from host 3, right? So the destination is P4, but because the source is different, right? IP address is already different, okay? So these are two independent connections. Okay, a unique connection is decided by 4 items, right? Source IP, source port, destination IP, destination port. Okay? So these are 2 different streams. Okay. Similarly for Skype, if host 3 has a Skype, I think this icon is missing. But anyway, so if there's a Skype application communicating with the Skype user here, right? So then you will have another link. Okay. So this is called a demultiplexing. If you look at this arrow, this direction, right? So upward, right? But if you think about sending, then it's a multiplexing. Okay, and it's uniquely, and each stream is uniquely identified by 4 items here, showing as a quadrant. Okay. So here's a revisit of our layers, right? So we don't consider session layer, and so we think about transport layer directly, then we have application layer, because the other 2 layers in the OSI model is hidden, right? So often in the application layer. Sometimes the duty will be taken by the transport layer. Okay, so let's just think about these 5 layers, and you know that network layers do care about what is in the middle, right? So routers. Okay, but transport layer, as I said, even you do congestion control, you are not aware of what's in the middle, right? So you are higher level than the routing level. So this is really the lowest level end-to-end protocol, right? So from transport to transport, you don't know what's happening in the middle, right? Application layer is a higher level, so, right? That's why we say transport layer is a lower level, end-to-end. Okay, you are only aware of the sender and the receiver. Okay, and down there, router will use the transport header as a payload, right? So because it's encapsulated, the transport level segment is encapsulated in the IP datagram. Okay, it's inside. Okay, so if you remember, IP datagram has IP addresses in the header, right? Transport layer, of course, you should have a port number in the header. Okay? And so this is the communication peer-to-peer. Okay. And now let's take a look at what's inside the IP datagram. If it's a UDP protocol, right? So UDP, the full name is called User Datagram Protocol. Okay, I believe when you get the socket programming, you are familiar now with the concept of UDP and TCP. Okay, UDP basically there's no congestion control, right? So it's just doing multiplexing and demultiplexing, right? Deliver to the right application, but there's no more complicated sustaining connection and all these other things, right? So it's connectionless, right? It's a single, okay? And if you program, you remember in a C socket, you need to say the dgram, right? So if you use stream, then it's a TCP, okay? And so these port numbers has 16 bits, which means you can have so many ports, 2 to the power 16 minus 1, because port 0 is invalid, you cannot use, okay? And bear in mind that those lower port numbers are reserved, right, if you remember. For HTTP, it's 80, right? So it's a reserve, like FTP is 21. So usually you will use something larger than 10,000, right? So then for your own application, okay? At least 1,000, right? So, and like if you look at some of the, like if you do the, like a Tomcat, they probably use 8,000, right? So if you use a Jupyter notebook, the server will use 8888 initially. Right? But if you have different server you want to connect and redirect to, then you should use like 8889 and increasing like that. Okay. And so, yeah, there is a payload length, which is a real data, right? But there's also a checksum. Remember, for IPv4 we have checksum. IPv6 we removed. Right? And in the UDP, in the TCP, again we have this checksum. Okay, so it's like a encapsulated data item. We still guarantee whether it's correct or not. Okay, it's double checked in some sense, right? So this checksum is for error detection, right? It can detect whether some bit is flipped, okay? If that's the case, even you receive this packet, right, this segment, you should throw it away, okay? And you should send, actually, you can send an NACK, NAC, okay? Meaning that I received that packet, but it's not valid, okay? You should retransmit, okay? And so this is why, even for UDP, you can know, hey, something you should drop, right? So for UDP, maybe we don't need to retransmit like TCP, but we don't deliver that to the application because it's corrupted, okay? It's like in your YouTube video, some frame is missing, but that does not hurt too much, okay? That's fine. You just miss one frame, which is for sure less than 1 second, okay? So unfortunately, it does not detect the dropped, right? So because it could be dropped in the middle, right? So some frame is dropped, thrown away by some router in the middle because of the queue of that router becomes full, but you never know, right? So there's no way to detect that. Okay, it's also not robust duplicated frame, right? If you have 2 frames that are actually the same thing, somehow retransmitted, or for some reason arrive again, right? You have no way to find that. Okay. And it could be reordered, right? So there's no order, right? So you can see some frame first and then see another frame that is earlier, right? So, but that does not happen often, right? So this basically, is UDP, right? So it only do the multiplexing, okay? It doesn't do anything else, right? So these things here, down here is done by TCP, actually, you will see that. So UDP is actually invented after TCP, right? Initially, everyone's using TCP. But why UDP actually still need to be invented, right? Why people still have that UDP here, okay? This is because not all applications can tolerate TCP, right? Because TCP is, have some additional benefits, but these benefits come with a cost, right? If you want a real-time games, real-time, you have high-stream videos, then guarantees the other like fairness, congestion, etc. Right? These all have overhead. Okay. So oftentimes congestion for TCP, you need to fix that by retransmit. For UDP, it's fine. I lose some of the frames, right? I miss some time of the voice or sometimes of the video. That's fine. Okay. So custom protocols can also be built on top of the UDP, right? And for those applications, then you need to make sure it's fine to lose some packet, or even lose a connection. Right? So like if you are calling Skype and the connection is really bad, potentially you will lose a connect. Right? So for them. And also, right, so there's no congestion control. Right? So if it's really bad, you just recall again. Okay. And examples are really like a real-time media streaming, right? If you are having videos, right? So online gaming, right? So, and this is real-time message passing, right? So messaging protocol. Okay. So all these are kind of real-time applications where you cannot afford additional overhead. Okay. Then you will use UDP. On the other hand, we have the TCP, right? So TCP, the full name is called a Transmission Control Protocol. Okay. Oh, before we move on, any questions? If not, let's continue. Right. So TCP is a lot more complicated than UDP if you look at the frame, the packet size, the packet format. Right. This is UDP. This is TCP. Okay. Again, you need a port number for multiplexing and demultiplexing here, right? But TCP is a kind of like having a connection, a sustainable connection between 2 parties. Okay, like a circuit, but it's called a virtual circuit because you don't really have a circuit throughout the route. It's end to end. Okay, it's just a virtual one established from the sender and the receiver. Okay, it's realized still using the packet switching. Right. Also has a flow control. Flow control means, for example, if you can send really fast, let's say your outgoing bandwidth is high, right? But the incoming bandwidth of the receiver is really low, right? So if you keep sending, it doesn't help because receiver will have to drop a lot of packets, okay? And then you should let the sender slow down, okay? So this is called flow control, right? Send it in a speed that can match the receiver, okay? And the congestion control is saying that, hey, now that you know, both sender and receiver can send in very high speed, but because some route in the middle, right, is shared by another stream, and that stream is already occupying a lot of bandwidth. So if you keep using flow control speed, that will cause a lot of packet loss, and it will not turn out well, right? Because you have to do retransmit in TCP, and retransmission further use some bandwidth, and then it basically deteriorates, right? So it's becoming even worse. Right? So we need to have another way of backoff by every party using that link, right? So so if you know the exponential backoff, right? So we talked about earlier, right? Everyone should, once they detect some packet loss, reduce the bandwidth by half. Okay, and because this TCP is respected by everyone sending through that link, everyone will reduce that bandwidth by half, and then things will immediately go better. Okay, and of course they will slowly increase. We will see that later. Okay, and after backoff, okay, until you hit a ceiling again, right? So we will see that later. And this kind of dynamic process actually can approximately guarantee your fairness. Right? So there's some delay, but ultimately, if you adjust for a long time, enough time, not very long. Okay, everyone will use basically, if you have 3 streams passing through a link, everyone will use 1/3. Okay, you will not have someone using maybe 90%. Okay, so why we need these features, right? So because we want to secure the transmission. Just think about you are sending a document to the other party, right? Of course, it should be ordered and nothing is missing, right? You send a very big PDF, okay, 10 megabyte, okay? And if you miss something, then the PDF file cannot be reassembled and displayed in your PDF client, right? And so, and if you have a session, you are doing Amazon, right? So online shopping, right? So you need a connection to set up and sustain. Right? So the connection setup, why do we need a connection setup? It's basically established state on both hosts. Basically, in their main memory, they maintain this connection, including the source IP, destination IP, source port, destination port. If you remember in the socket programming, once you establish such a connection, right, then you can just send stuff to that socket. Right? This is like if you do online shopping and you see, hey, that product I'm interested, I my cart, right? So it's okay, right? So you just you use that connection, right? And so the most important state in a stream, right, in a TCP connection is sequence number. Okay. So the sequence number, we'll see that later. Okay, when you establish a connection, you will randomly sample a sequence number initially, right? The sequence number is 32-bit. Okay, so that's for security reasons. Okay, there's some other people can attack you and hijack your message. If you use stuff from random numbers, then it's difficult for them to achieve that, right? And there's some other reasons. We will see that later. Okay. And the sequence number is also useful to count the number of bytes that have been sent. Right? So both parties will see, hey, what's the sequence number of those contents that have been received? Right? So you continue to receive the additional ones. Okay. Yeah. Any questions so far? If not, we'll continue. Right. Another important thing that you want to be aware of is there's a flag field here. You see, right? There are, I think, 12 flags. Okay. So 12 bits, right? So each bit is a flag. So we are particularly interested in 3 bits. Okay, one is called a SYN, which is synchronization bits. Synchronization is for, if you want to establish a connection with the other party, both of you need to synchronize, add a state to each side. Okay. And because you have the state maintained on each side, then you know whether some packets are received or not, right? And whether some retransmission need to be done. Okay. Another is a ACK flag. Okay. ACK means acknowledgement, right? You can see always the first 3 letters in the word, okay? And because when you send to the other receiver, right? So how do you know it's successful? You need the receiver to acknowledge that, okay? Otherwise, you have no way to make sure it's reliable. TCP is a reliable connection, okay? And so finally, after you are doing online shopping, you're done. Right? So you want to say, hey, I want to log out. I want to finish this, right? So you need to have another flag called a called a finish, okay? Used to tear down the connection, right? So the problem, if you don't tear down the connection, what will happen is the server in the main memory, right, it will maintain your session, right? And then you think about Amazon has so many people do online shopping there. If they never tear down any connections, things will go crazy, right? So their memory will run out, okay? And even if you don't purposefully log out, right? So oftentimes the server will log you out after, let's say, 30 minutes or something, right? So this is for the same reason. The server just wants you to save, right? The memory can be released, right? Okay. Now let's first look at the connection establishment, right? So how to set up the connection. So I'm not sure whether all of you guys have heard of this term called the three-way handshake. Right? It's quite famous for TCP. Right? So this is a process that you establish connection with the other party for TCP connection. Okay. So of course, someone need to initiate the connection. Right? So hey, I want to establish a connection with you. Right? Oftentimes, if it's online shopping, then you as a customer, right, client need to establish, right? So server is just a passive. Right? If you want to do shopping, hey, I also. Okay? So here's, for example, synchronization, right? So, and you will give a sequence number from the client, right? It's a randomly selected sequence number here, right? Once you establish, server will know it, right? Then if you continue to send more bytes, you will add the client number, right? The server and the client will know how many bytes are received. Okay. So the second, this is your, as a message sender, this is your sequence number, so far, right? It's starting sequence number. Okay. This zero is zero because I haven't got the other side, the receiver side sequence number. It's still establishing the connection. Okay. So I put the zero here. The server then, if you receive this synchronized message, what it will do is it will acknowledge, hey, this message is sent. Right? So this is a to achieve that. Right? So this is more like a one advance the sequence number of one, okay, plus one, meaning that this is received. Okay, and in the meanwhile, the server, as a sender side, right, it will also randomly select the sequence number and put here. Okay, and then the client will know now, hey, what's the sequence number for the server? What's the sequence number for the client? Right, the server already know here, by the way, right? So it knows the sequence client and it selects the sequence. Okay. And then the client will have to acknowledge that. And so this is say, hey, I want to. You can think like this. Hey, this is my sequence number. A server say, hey, this is my sequence number. Okay, and then client need to acknowledge that server knows, hey, client actually get my same message, same execute. Okay. So this is acknowledge, right? So then because these two messages are received, so plus one. Okay, and so one thing you can see here, this is called the sync, right? So synchronization and acknowledgement. Right? So this is because acknowledgement of the client is client plus one. And in the meanwhile, we are doing a synchronization with the client for the sequence. So, okay. On the other hand, this is only acknowledging this is received, so it's plus one bits. So this is called a piggybacking message, right? So because you can have multiple information in one message and you just send once. Because you think about it, if you this is the transport layer, right? For each message, each packet, you need to attach the other additional headers, like the IP header, etc. Right? So if you can combine two messages in one message, this will be much more efficient. Okay, so this is a three-way handshake. You only need three messages. So each side will notify the other side's starting sequence number that it selects randomly. Right? As we said, it's random selection for security. That's one important reason. Okay, and it also acknowledges the other side, that the starting number. Right? So hey, I know your you plus one means I receive this. Right? So initially you start from here, but you send I plus one means hey, next the message should start from client plus one. Okay, that's why it will send the client plus one. Yeah, here plus one means you receive something, you need to acknowledge, you advance the sequence number. Okay. So here's an actual example. So let's say this client samples 2000 as an initial sequence number and send to the server. The server will say, hey, I received that. Now you should send me 2001 next time. Okay, this is acknowledgement. This is also the synchronization. I selected the 5000 as the random initial sequence number. And then the client need to acknowledge, hey, now I'm really sending 2001, right? But I acknowledge your 5000 you received. I advance by one, meaning, hey, server, next time we send something, it should be 5001. Okay? Any questions so far? Right, so this is a through handshake. After this process, the connection is established. In your programming concept, and the socket will be returned. Then you can use the socket to send whatever you want. You know that it's between the client and the server. Okay. And so that the connection setup with some issues, right? That's why we needed the random sequence number, right? So firstly, this is for connection, connection confusion. Right? So the reason is that there's still some chance that both sides will, after a connection is teared down, right, using a thing, right, we will see that after tear down, the connection will remain effective for a while, okay? Because, you need the other side also to tear down, right? So you need to remain open for 30 seconds or 1 minute or something, okay? So in that case, if you now establish a new connection, unfortunately, you are using the same port numbers, right? Then there will be confusion, okay? So this is called a connection confusion. Now, if you randomly sample sequence number, right? You know that the sequence number for the previous connection are kind of in a different range from the current sequence number. Then there's no confusion. Okay, so this is one important reason that's in non-security. Okay, why we need a random sequence number. So there's another concept called source spoofing, right? So, so this is regarding security. So what it means is that, for example, if you have a packet, let me give you an example. For example, let's say this guy is an attacker, okay? Attacker. But what I want to attack is this guy. Right? This is a vulnerable, right? This is a vulnerable person, okay? But I don't attack you directly. What I do is I will send some message here, okay? Let me see. Yeah, I send something to this guy, okay? But in my packet, right? I say, hey, I'm not myself attacker. I'm the vulnerable person, okay? Right. So this is called a source, source spoofing. Okay, the source IP address is not me. I use other people's source IP address. So if you are malicious, you can of course replace that. Destination is still the destination. Okay. And then this is called a source spoofing. What happens is the router. If you remember the router will not check your source IP address. Okay, it will only check the destination IP address and look up the routing table internally and decide where to go next, right? So the source address is only used by the destination to decide who I want to reply in the TCP connection. Okay. So because you are using a fake one, which is actually this person, right? So you will, this server will send to this guy. Okay. So the attacker can do this to multiple services, right? Let's say, let's assume this is let's say, hey, I give you a question, right? And I say I want to take exam, right? So just think about how we are taking exams using the quiz, right? And then hey, complete this exam for me, right? So this client needs to do a lot of workload to finish the exam, right? Exam. Right? You think about the attacker establish many connections, and then these traffic delivered to you, and this variable host will be totally overwhelmed, right? So this is one kind of attack that you can perform. So to avoid that, we can use a random number generator, right? So think about it. As an attacker, you need to negotiate your random number with the server for that. And then this vulnerable person, it's your random number, right? So this guy will find, hey, something wrong here, right? So it will not answer your connection. Okay, so this random number is also safe in this aspect. Okay, so we need a random sequence number. If you always start from 0, for example, then you have no way to differentiate the attacker. So there's also, connection state management. Right? So you can flood the synchronization. Right? So basically, let me see where we were. If you remember the through handshake, if I want to attack you, okay, I can do this really malicious thing, right? So I say, hey, server, I want to establish a connection, but I'm not myself. Okay? I'm saying I'm the other guy I want to attack. Then the server will return. This is called IP spoofing. Another way is you are not attacking this guy, you're attacking the server, which means all you do is you send some synchronization to the server. Right? The server will maintain some information here and send it back. Okay, send it back. But then you never acknowledge it again. Okay? You're malicious, right? You send another synchronization, creating different port numbers. Okay, you just keep doing this, right? And what will happen is that you will exhaust the server results. Right? So it will maintain the connection information, but actually it's never functioning. Okay, it's all you are doing is just to use this synchronization to plug the server. Okay, and once the server is memory out of memory or it's busy answering your thing, then it denies the service of other normal traffic. Right? So this is called the this is called a sync flood. Okay, you just flood saying you don't get acknowledgement, right? And it's called a denial of service attack because then you keep the server busy and exhaust its results. It will have no way to serve other clients that are normal, right? And there's also a concept called a DDoS. This is DOS attack. DOS. There's also another name called DDoS attack, called a distributed DDoS attack, right? So the difference is that DDoS attack, you see, you are always this close, okay? Then the server can observe that you are synchronizing, but it's starting from the same IP address, right? Then I can add you to a blacklist. I don't answer you. Right? After a few attacks, I tear the content down and I say, hey, you are malicious. Right? So this is actually used a lot by a lot of the servers. Okay, when you register for account for a 100 account, for sure, maybe not even 100, register for 5 account, which is really weird, they will ban you for that. Okay, and to avoid this from happening, you have a DDoS. Okay, DDoS is distributed. So what you will do is you first send out some malicious, like malware, right, to other people, right? Like hey, some email message, right? So, but the email says, hey, like you will fail the calls. Okay, try to click this link, right? But apparently it's not a Canvas link. It may be a Canvas link or something, right? So it's really, really some malicious link. Right? It's try to fool you to connect. Okay, after that you connect, and then it runs some background malicious code, and now you become a bot, right? If this guy can handle, can really fool enough people to click, then it will have control of a botnet, and then it can give command to this botnet to attack this server, get to send sync, right? And by doing this, the server will see, hey, let's say 10,000 machines are sending thing to me, but not answer. But I dare not ban any bot, right? Because there's not enough traffic just sending from here, right? Each bot may just send 5, right? 5 things, maybe still normal, right? So this is a way of attacking, right? So in that case, the IP address of those bots are totally different. You cannot ban, right? So then for this case, even if you start with random numbers, or so you have this is connection setup. There's no relation with sequence number anymore. Right? Even doing this, right, you are in trouble, right? So you cannot ban that attacker, right? Because there are so many bots. Okay, there's a botnet attacking, but you still want to avoid that. Right? So the solution is called the sync cookies. Okay, so what the sync cookies is doing is that, remember previously, let's say this is your main memory. Okay, once someone is connecting with you, right, you respond. In the meanwhile, you will maintain something in memory. Right? If someone sends another thing, you will maintain another thing. Now the sync cookie is saying, hey, I don't want to, at this point, I don't want to add anything to my memory. Okay, but I will encode something into my sequence number, and I will send it back to you. This sequence number is a meaningful sequence number. Okay. If you truly are not an attacker, you will acknowledge me. Okay. I will verify, hey, this is a meaningful sequence number. Then I will add something to the memory. I will not add memory right at this point, because you may never send an acknowledge back. Okay. So this, even if you have a botnet, it's okay. I just respond to some message. I don't occupy some results. Okay. So this avoids the DDoS attack. So this is by the sync cookies ID. Right, any questions so far? All right, so because today we are not taking attendance, right? So because so we will randomly take attendance. Okay, so on Friday, let's be a little relaxed. Okay, so far we talked about how to establish connection, right, through a handshake. Okay, there's also a connection tear down. Right? So let's say you finish the connection, you don't want to keep. Well, I think I mentioned this to people disconnected. Okay. So so you want to tear down the connection, right? So because you don't want to occupy the resource on both your side and the server side, right? So what you can do is you send a thing, right? Finish, okay, and with your last sequence number. By doing this, what you are saying that you are telling the server, okay, I'm not gonna send anything more, right? From client to server side, I'm done, I'm finished, okay? So client want to say, I want to tear down the connection. But the other side, the server, for example, can still continue to send you some message, right? So you can do some processing, okay? It's a passive, right? You will not send another message to the server, okay? And you can receive some data and save it, right? Let's say, hey, I'm done now, right? But it sends you some transaction ID or something, right? So you need to keep track of later, right? So you will save in your like a local cookie or something, okay? So in this case, we call this is a half open connection because server can still send to you, but you will not send anything to the server, okay? Because maybe something is still ongoing, right? The server cannot just suddenly finish. And now, well, after server is done, right? Server can let me see. So after you should still you are not sending new message, but you should still acknowledge server state, right? Because if you don't receive that, server need to retransmit. Okay? Finally, after you acknowledge the last thing, right? The server finished the last message. The server will tell you, hey, now I will not send anything, right? I stopped at sequence speed, right? And again, you need to acknowledge that server, right? And only by this point, client will not send anything to server anymore, and server finish the last batch of data and will not send anything more, right? And the client acknowledges that, right? And at this point, server knows I'm done. I delete all the results from my memory, okay? And in the meanwhile, the client cannot, right? So the client cannot just, after sending acknowledgement, the client cannot just tear down. The connection should be maintained, stay open for some time, okay? To round trip time. The reason is very simple. You think about this technology can be, right, if there's a congestion, right, so this packet, the technology packet can be jumped, okay? In that case, what will happen is the server say, hey, you didn't answer me yet. I will send another thing to you, right? So you need to remain open for a while, right? So usually 30 seconds, sometimes 1 minute or 2 minutes, right? And until, after 2 minutes, you are pretty sure, for example, this is really, even a retransmission and congestion should be resolved, right, after 30 seconds, okay? Then you can tilt it down. So you can see there will be sometimes the connection is still there, okay, right, for 30 seconds. In that case, if you have a new connection with the server, will happen with the same port number, you're in trouble because the sequence number is in trouble, right, if you start from in the same range, okay? That's why if you randomly sample the sequence number, then this sequence number range at the end, right, will be different from your starting sequence number. You know that it's a new connection, okay? So the server will be able to know what's happening, okay? All right, so here is a sequence number space. Let me see. I don't think we have time to finish this, so let's continue next Monday. Okay. If you have any questions, feel free to ask. I will be here for 1 minute. Otherwise, that's the end of the class, and have a nice weekend. Thank you. Yeah, we do have a lab today. Okay, so today will be the last lab. Okay, it's April, right? So today is the last lab. Once you finish by next week, we will have no lab. Okay. We will have enough time for you to work on a bonus project. Clark, can you explain your question? I don't quite understand. Which assignment are you talking?
So I'm talking about the next assignment. There's no way to submit it, basically. There's no like actual assignment, like lab 5 assignment page.
Oh, really? I think the TA forgot to create a submission. Yeah, can you talk to the TA during the lab session? TA will handle that.
Okay, I'll mention it. Thanks.
Thank you. Okay, any other questions?
Professor, final project, is it like, can we, is it something to do with like secondary research, or can we do any?
Yeah, we can allow an open research as long as you send a paragraph of what you plan to do, okay? And we will get more instruction next week, okay? But we will have a recommended project for you guys, okay? It will be, maybe if you think it's too difficult, you can choose the one that you prefer. It's okay?
All right. Thank you, Professor.
Welcome. Yeah, if you have a missing lab that you submitted, just send to the TA that is responsible for the lab marking and copy me. Okay, we can see how to. But if you didn't ask for extension, we have to deduct some late penalty. Okay, but just send an email, so we will make sure it's ready. Okay. I hope I answer your question. Okay, I do not see any new question coming up. In that case, I will. Yeah, if you have an extension, right, then just a reply from that email thread. Okay, then we have the record of that. Okay, thank you. All right, so I will see you guys next Monday. Have a nice weekend. I will upload the video to YouTube. Okay, thank you.